sharing my screen.
This meeting is being recorded.
Got it. Thank you so much for this lovely introduction, Irina. I think that
we don't hear you.
I can hear you, Nadia.
Can you hear me or not?
Okay, so that means that's only mine. Okay, okay.
Could you let us know in the chat? Okay. Oh, okay. Yeah, good to know. Cool. Yeah, thank you so much for the lovely introduction. I think Irina mentioned a lot of great things about Women Who Code and why it's a great organization to be a part of. I'm very sorry. Probably you can hear my kitten in the background, so he might want to join the presentation. Yeah, today I'll be talking about S.O.L.I.D, as Irina mentioned, and just to start with a few words about me so that you know who I am and where I'm coming from. So my name is Nadia. I'm a full stack engineer currently working at Intercom. And Intercom is a company that builds software that allows businesses to talk to their clients. So things like chats and chatbots are some of the products that you might have seen from Intercom or perhaps from other companies as well. Sorry, the cat is here. I am a self-taught engineer. I used to be a journalist and an editor before I learned to code. I'm also a book author. I also blog quite a lot. So the easiest way to follow me online would be by my handle Bittlehope. So if you have any questions or you would like to keep in touch with me or maybe follow some of my work, that would be a nice way to do that. I also enjoy giving back to the community. So I volunteer at an organization called Code Your Future, which is a coding bootcamp that teaches people from disadvantaged backgrounds to code. And I am also, as mentioned, lead at the Women Who Code London. I'm also a career mentor. So these are some of the things that you might want to talk to me about, and I'll be glad to connect afterwards. So today we are talking about good design and principles of design. So just to start with, we might want to kind of understand why design is important and why should we care about design at all. And by design, I mean the arrangement of code. So not like visual design, but mostly like how we structure programs and how we arrange them. So I'm curious to hear your opinion. Why is good design important in your mind? Sorry. You can raise your hand if you want to say something. I'd really love to hear your voices. Sure, go ahead.
So it can allow us to update things easier if there's any advancements in the future.
Mm-hmm. Great point, thank you. Anyone else? To be honest, that was my answer as well. Good design makes your code base easy to change. I've actually heard I don't remember who said that, but it was some opinion leader in the coding community who said that ability to change is actually the most important metric in software design. So we need those kind of conversations about design, mostly because design is difficult. And why is design difficult? I think for many reasons, but mostly because the code that you are building needs to do two things at the same time. So first, it needs to solve the current problem. So you're being paid to solve problems, so you need to solve it. But also the code that you're working on, it needs to anticipate the future need for changes. And of course, this is very difficult because we are not psychics, at least not most of us. And we don't know the future requirements. We are building the code, but we don't know what will be required of us in the future. So we as programmers rely on design principles to kind of solve this problem in a way. We rely on certain principles and heuristics that were discovered earlier to make those things easier. And the goal behind this lecture is to show you some of the principles that programmers use when working with object-oriented programming. There will be many other lectures within Women Who Code object-oriented programming track. So the next one is in 2 weeks, if I'm not mistaken. And there, my colleagues from Women Who Code London will be telling you more about other principles and design patterns that you can use when designing your code. And I do encourage you to attend all of them. Those things are not mutually exclusive. And the principles that I'm talking about today are not, exclusive of the ones that other will be talking about in a few weeks. So you can choose and mix and match as you see fit. There are no rules that are set in stone. These things exist mostly to help you and not to limit you. So I like this graph from a blog post by Martin Fowler, who is a very famous person in software engineering. It kind of shows why design is important. So he talks about the fact that people sometimes ask him whether good design is worth it, because you need to spend time planning how you will write your code instead of just going and writing your code. So he shares this graph where you can see that there are 2 projects. So the one in red is the one with good design, or like any design. And then the one in the blue is the one with no design. So you can see in the beginning, and the y-axis is the functionality, so how many features you can deliver. And then there is time, so how much time it takes you to deliver features. So you can see that initially, actually, the project, the blue one that has no design, it actually allows you to deliver functionality quicker. But then you come to a point where the one with good design actually allows you to deliver functionality much quicker. And then this will go on forever. And probably some of you have worked with projects where the project has become so complex and just and has accumulated so much bad code and so much technical debt that it has become impossible to add new stuff. And that's kind of the what this picture talks about. So what is S.O.L.I.D? S.O.L.I.D is an acronym. It was created by Bob Martin, who didn't invent all of those principles, but he solidified them into this acronym. So it refers to 5 fundamental principles that help engineers write maintainable code. And we can think of these principles as the foundational elements that we can use when evaluating the health of our code base. I will go through those principles now, but please let me know in the comments whether you have heard or worked with any of those principles ever before, and whether, let me just put that, whether you have heard of them, whether you have worked with them, whether any of those names ring a bell. It will be just helpful for me to know how much context you have for those things. So S.O.L.I.D, the first one, single responsibility principle, open clause principle, Liskov substitution principle, interface segregation principle, dependency inversion principle. Let me look at the chat. Okay, I see that some people have heard of them. Some people are new, never heard of this. Again, 4 design patterns, exactly similar thing, complete beginner. Cool. This doesn't assume any prior knowledge. I was just curious. So to be honest, I have I use some of those principles in everyday life, but I never refer to them with their names. So it's not like you're working with code and somebody is just like, oh, you're not using interface segregation principle, you should fix it. It doesn't really happen. But I would say that knowing those principles, not their names, but what they mean, is actually very helpful. So while preparing this presentation, I had to do some research and remind myself what those principles meant, like how to map the name of the principle to what it does. So what I want to happen within this lecture is that you don't focus on remembering the name, because they are very complex. Also, they can be similar to each other and they can be kind of confusing. So I just want you to focus on the main idea behind the principle. And if you leave this talk remembering 1 or 2 of them, one of the 2 main ideas, I think this will be a huge win. And it can improve the quality of your code base significantly. So now I will go over each of those principles, talk through them, talk through some code examples. Those examples will be in the Ruby programming language, which is my primary language of choice. It's a dynamic interpreted language for those who haven't worked with it before. It has a very straightforward syntax, and I believe that it's easy for beginners, But also, if you don't understand some of the code examples and something doesn't make sense, please don't hesitate to raise your hand and ask me. I can explain in more detail. Yeah, I really hope this talk will be interactive. And I will be asking questions. And when somebody asks a question and nobody answers, it just feels very awkward. So let's try not to have those awkward moments if we can. So first principle, single responsibility principle. The class should do the smallest possible useful thing. So this doesn't mean that the class can do only one very narrow thing. It means that everything the class does needs to be related to its purpose. So it's probably my favorite principle in S.O.L.I.D, and it's the one that I use most in my day-to-day life. Another way to kind of think of it is that you can look at your class in your code, and you can pretend that it's alive, and you can ask it, like, what are you doing? And if the answer that the class gives you contains the word and or the word or, it means that the class has a few responsibilities. Also, you can try to describe what your class does in just one sentence, right? So another way to think of it is that the class should have only one reason to change. So we say that anything that gives the class a reason to change can be seen as its responsibility. And when I say change, I mean structural changes to the class. And let's look at some examples. I think it will be easiest to understand what the principle says. So here is an example. Here we have a class that's called deal processor that processes deals. The first method in the Ruby class is initialize. So it's a method that initializes an instance of a class. It accepts deals, which can be like an array of deals. And the main method here is process, where we go through each of the deals. For each deal, we create a commission. Here is how we calculate the commission. Then we mark the deal as processed. And here we have private methods. When we're marking the deal as processed, very simple. We're just marking the processed flag as true, saving the deal. And when we're calculating commission, we have this calculation, which doesn't really matter for the purposes of this discussion. So can you think of reasons why we might want to change this class? Let me see the chat again. Does anyone have any ideas? Yeah, it's not a strong type language, it's dynamic. And I say that it's type. Yeah, if I said that it's type, sorry, it is not type. Yeah, so one reason to change the class is exactly as I see in the chat, to change the calculation. This is one. And what else? Do you see anything else that might change that might ask us to change the class? Multiple methods. Yeah, it's kind of close, actually, the multiple methods version. So one thing is that, yeah, if we decide to change the calculation, how we calculate the commission, we'll need to change this class. Imagine if we just change this calculation, or maybe we want to add more logic to it. So this is obviously a very simple example. Maybe we would like to, if this is like a big deal, a huge deal, we might want to calculate the amount of the commission differently, and then we would have some if statements here and like a lot of logic. But another reason to change is that if we are processing the deal and we are marking the deal as processed, here we are just marking it processed equals true, right? But imagine if we want to start sending emails, for instance, for the seller who closed the deal, or something like sales agent who closed the deal. So then we might need to change this as well. So you can see that we have multiple reasons to change this class, which is a signal that this might actually break single responsibility principle, because this class does a lot of things. Here is one way that we could refactor this code, and this is just one way, and this is not like final, perfect code. So here we have the same class, but we add another class, which is called commissions calculator, which encapsulates the logic of calculating the commission. So we have two classes, each handles one specific task. And here you can see that this is not the perfect code, and we can continue to refactor it. And I just thought that I would leave it this way. to make it really clear what changed. Why, if you like, maybe you have some ideas, why do you think this after the one on the right, why do you think it's better, and what benefits do you see to the code on the right? Any ideas, any benefits? You can also raise your hand and give an answer. It's not an exam, we're just learning from each other, so it doesn't matter if you're wrong. Okay, I'll answer. So one obvious thing I think is that it's easy to reuse this code. For instance, imagine that you need to calculate commissions in some other place of your code. So then you can just, okay, what happened? Sorry. So you can just reuse the this class as it is, right? You don't need to write the code again. You can just reuse the code that you already have, which is cool. Then what else? I think that the code is generally easier to, sorry for the noise. So in general, this code, I think, is easier to understand and kind of easier to follow as well. Yeah, so these are some of the benefits. Okay, let's go to the next one. So the principle of single responsibility can actually be applied everywhere, not only on the level of classes, but also on the level of methods. For instance, here, you have an example of a method called demeters, which is simple, which looks simple, but actually it does break it does break single responsibility principle. So here you can see we have a bunch of, it's a still example about wheels and calculating their diameter. So we have a bunch of wheels here and we loop through each of those wheels, and for each wheel we calculate their diameter. So the problem with this is that you have one method that does two things. It calculates the diameter of one wheel, and then it calculates the diameter of a bunch of wheels. So a simple way to follow single responsibility principle here would be to separate those two things. So first you have this method on the bottom, which calculates the diameter for just one wheel. And then you iterate over the array and you calculate the diameters of all the wheels. So I think that why single responsibility principle seems so important to me is that you can apply it not only to classes, but also to methods. And kind of throughout the code, this can help you write smaller maintainable code that it's easier to test, easier to refactor, and easier to reuse. So any questions before we move on to the next principle? Or if you have questions about Ruby, I will be glad to answer if any of those examples don't make sense. Could anyone raise their hand, because it will be a bit easier for me than follow the chat? Or maybe, Irina, you can read out the question if you could, if there are questions, of course.
Yeah, I'm not asking. These classes appear to depend on each other.
Okay, can you explain again? Okay. Which classes are we talking about? Okay.
It was about the previous one.
In what way do they depend on each other? So in a way that to calculate a commission, you need to instantiate the commission with a deal. In this case, yes, but I don't think that we can think that this is a dependence. I mean, it is a dependence, but I don't think it's a problem. Anna, could you maybe unmute yourself and ask the question? You know, it will be easier because I'm not sure I understand your question. Okay, never mind. If you want to ask a question later, we can return to this. For now, let's move on. Okay, so the next principle is called open close principle. So it says that classes and methods should be open for extension, but closed for modification. So what does it say? So it tells us that we should try to move to modular designs that make us possible to change the behavior of the class without making modifications to the class themselves. So you can think of it as the idea of taking immutable data structures and applying this idea to coding. So once you write the code, you never change it. So how do you achieve it? One of the ways to achieve it is actually through different abstractions. So one abstraction is, okay, sorry about that. So one abstraction that you can use is actually called strategy pattern, which is a pattern that we will be talking about in one of our future lectures within Women Who Code. So I'd encourage you to join in the future to learn more. So I will just briefly give you a short example of some code that does it. So here you can see the class called usage file parser. This is a class that just deals with parsing different files. So we initialize it with, if anyone can tell me how do I remove this thing from here, it would be really cool. Okay, I'll just do it manually. Cool. So usage file parser, it accepts a file. And the main purpose of this class is to parse files. Here you can see that depending on the format of the file, we parse them in different ways. And here we don't care about the exact details of parsing the file. We just care, that the correct method gets called. So here you can imagine that if we need to add a new file parser, we would have to modify this class, which, according to the previous slide, breaks the open-closed principle. A way to avoid that and a way to make it better and not break the principle would be to do something similar to what is here on the right. So here that is that we create separate classes for parsing files. We have a separate class called XML parser that has the method called parse. Then we have the class called CSV parser that also parses files. And in our main class, we just basically we expect to receive a parser. And this is something called duck typing, which means that we don't care about what an object is. We just care what methods which methods it implements. And in this case, we just want something, we don't care what, that implements the method parse. This code is better because it allows us to easily add new parsers to the setup. So you can imagine if you are adding, you can add 10 more parsers and the original file won't really change. And this method of doing it is called dependency injection, which is a very fancy word that used to scare me a lot when I was a beginner, but actually just means that dependency injection is when you're initializing a class like here, you are passing in the dependency that it needs to work properly. That's it. And another way to not break open-close principle would be with the decorator pattern. Here, a decorator is something that allows you to add new capabilities to a class without changing the class. So here we have an example of a class which is called simple writer. It is very simple. It just goes through text and it prints the line, separating them by a new line. That's it. Then we have a separate module, which is called timestamp writer. It does similar thing, but it adds a timestamp to the line. And then another one, which is called numbering writer, which adds the line number to the output. So having those decorators allows us to dynamically mix in the new behavior. So we use the keyword extend in Ruby. So here the extend method inserts the module in an object's inheritance tree before its regular class. So you can imagine there is a class And then if we do the extent, then the module that you mix in will be before the regular class that the object inherits from. So in this case, the last module added will be the first module called. This is super confusing, but you can see here in the output we would have the timestamp, and then we would have the number of the line. So kind of all of the classes got applied here. And in this case, you can imagine that you can have many other modules. You can add more functionality without changing the initial file. So let's go over to the third one. The third one is Liskov substitution principle. This is what it looks like in the world of math. I'm not even going to read it. To me, all of this kind of looks this way. Doesn't make much sense. So a more human readable version would be this. You should always be able to replace the instance of the parent class with an instance of one of its children without negative side effects. Still, this probably sounds a little bit confusing. So here you need to think of a couple of things. So first, you need to think about object-oriented inheritance. Hopefully you're familiar with it. If not, just super brief explanation. You can think that there is a class called animal, and then there is a class called cat and a class called dog. And both cat and a dog, they inherit from the class animal, which means that they have access to the methods defined on the animal, but they can add their new methods and they can override the methods of the parent. So this is like the basics of inheritance, and this is all you need to understand for this example. And in order not to break Liskov substitution principle, you need to be able to replace the instance of a parent class with an instance of a child class. I'll go over an example. I think this will be easier to understand with an example. So here we have a class called user that has a couple of attributes, settings, and email. We have an admin user class that inherits from the user. So this is a parent, this is a child. So here we create a new user with an email, and then we decide to add settings to the user. And we have a hash. We have like level of security, status, and when they were signed in. Then we create an admin and also set settings for them. But here we decide that we don't want to do a hash format. We can do just a regular array, and we just pass in editor, VIP, and date to date. So, and then we are just outputting this information. So from the outside, everything looks fine, everything works. And, you know, it might be like not really obvious why this is wrong and what might happen. However, this becomes clearer if we go to the next screen where we decide to add a new functionality. And this is what always happens. You write some code, but then you have to add something new. And this is where the danger comes. So here we have a new code here on the bottom, method called signed in today. So basically a method that goes over all of the users and checks whether they were signed in today, and then writes their names into some report or file, whatever. So you can see here that we're checking in the settings hash whether they were signed in today. I don't know if you have an idea what would happen if we run this code, if we run the method signed in today. Do you think it will work, or do you think it will break? It's a very loaded question, but I'm trying to be interactive. Okay, I can give you an answer. It won't work. So that's the mistake, that's the error that we would get. So why is that? I can go back to a previous slide to just show you. So this code will work fine for the user because the user settings are in the format of a hash. So this will work great. However, when we go over to the admin, admin settings is an array and it doesn't have a hash key because it's not a hash. So it will break because of that. And this is the error that we'll have because, yeah, this method is not, the hash key is not there. So does this break Liskov or not? I think that it does because we are not able to replace the child, the parent with the child. We're not able to take the admin user and replace it for the regular user. how can we change the code so that it doesn't violate the principle? This is one approach that we might use. Basically, it's a similar code, but we would have a method in the class user that would force the settings to be in a certain format. Here, we use something that's called open struct, which is a way to create like hash-like objects in Ruby. But basically, you don't need to understand like any details of it, but it's just that we need to enforce on the level of the parent what format this attribute will be in. And in this case, every child that inherits this method will be kind of forced to provide the methods the settings in the necessary format. And then we would be able to replace children with parents and vice versa and not break Liskov. I was told while preparing the slide that this example doesn't make sense for type languages such as Java, because in Java, a thing like that would never happen. So I thought I would also present an example in Java. Here, imagine we're writing an application for a bookstore, and we need to add functionality, book delivery functionality. So we create a book delivery class that informs customers about the number of locations where they collect their order from. As below, here we have a book delivery class and the method that returns the delivery locations. Then we also want to deliver posters, and we create a new class called poster map delivery. It inherits from book delivery, and it overrides this method get delivery locations, and it returns some other locations for this particular case. But then suddenly we're told that we also need to deliver, to sell audiobooks. And we still kind of have this method, but then the question is like, what do we do? Because we cannot have a physical location for delivering audiobooks, because audiobooks are not physical. So, it can be done like in different ways. Sometimes people actually would like raise an error in this case, but this would also break Liskov, because we wouldn't be able to replace an instance of a parent book delivery with an instance of a child of audio book delivery. Because imagine that there is some other code somewhere in the code base that expects this method to get delivery locations to return, for instance, an array of addresses, right? And then all of a sudden, in one case, you would get an error or maybe some other output that is totally unexpected. And this code would break because it receives some output that it was not prepared to handle. So a way to fix this would be actually to change the inheritance. And we can, I think it's a separate topic about inheritance and how many problems inheritance solves and how many it creates. But I think that very often fixing inheritance can be a quick way for you to fix some of the S.O.L.I.D violations. So in this case, we would have a couple of different subclasses. We would have an offline delivery one, and then we would have an online delivery one. So this one would return physical addresses, and physical objects can implement this one. And then we would have online delivery that would return software delivery options, whatever this might be. And then here on the bottom, you can see that the class that delivers posters, it can extend the offline delivery. And then the one that the audiobook delivery, it can extend online delivery. And this way, the world won't break and everything will work as expected. So this was L in S.O.L.I.D, Liskov substitution principle. We have 2 left. Okay, any questions so far? Okay, I see that it does happen in Java. Interesting. I haven't worked with Java, so cool. No questions, so let's move on. Hope you're saving your questions to the end. Cool. So interface segregation principle, the I. Clients should not be forced to depend on methods they don't use. So this is a principle that we don't talk about in Ruby, because Ruby is not a typed language and it doesn't really have interfaces. So I'll give an example in Swift. So the idea here is that when you're thinking about interface segregation, like what does it mean? What does it mean to segregate interfaces? It just means that you need to have many small interfaces rather than few large interfaces. So you kind of segregate one large interface into many smaller ones. This is the way I think about this principle. So to show an example, Here we have two classes. We have one called document that accepts a string for name and a string for content. And then we have a class called PDF that takes a document and then creates, processes it and creates a PDF with it. Then we have our interface, our big interface called machine. So it has a couple of methods. So we have a method that converts a document to a PDF, a method that converts a document to a UI image, and the method that faxes the document. And then we have three classes that implement this interface called machine. So we have a fax machine, new iPhone. So this one, fax machine, new iPhone, and Ultra machine. So fax machine is the one that is capable of implementing the fax method. So because it wouldn't make sense to implement other methods of the protocol, but since the class implements the protocol, it is forced to implement all of its method, right? So it just returns new for all of them. Then for a new iPhone, kind of a similar issue arises because it can't really fax a document. So here it can also return nil. Here it just does nothing. And then we can have an Ultra machine, and it's a machine that does everything. So it converts documents, it faxes documents, it does everything. So do you see any potential problems with this implementation? Anything that doesn't look right to you? Anything at all? Do you like this code? What do you think?
Lots of unused functionality.
Mm-hmm. Yeah. So there is code that kind of doesn't make sense. It doesn't really make sense if you think about it like from afar. Like, why does a new iPhone have a method called fax, right? It doesn't use it. If this method changes, for instance, so imagine that we change this interface machine and fax method, it starts accepting different parameters. Then new iPhone will have to change as well, which makes no sense because the iPhone is not able to fax things. So semantically, it's more difficult to understand. This is a very simple example, but you can imagine this growing and expanding over time. So you can imagine that we will have like hundreds of methods, and this whole thing will be much harder to understand and work with. So a way to solve this, and this is like an initial step at it, and we can continue refactoring it, would be to define two protocols instead of one. So kind of separate the responsibilities, coming back to the single responsibility principle, we can have a protocol that converts documents and the one that faxes documents. And then fax machine implements the fax protocol, and the new iPhone implements the document converter protocol. We can continue refactoring it. I think you can see that we can also divide this into two separate protocols, one for PDF and another for other formats. But I just kind of stopped at this one just to show you a point of how this might be, how this might be applied and how this might be changed. So as always with refactoring, there is just a starting point, and then you can continue from there. And the last one, we have, I think, 11 minutes left. So the last principle here is the D, dependency inversion principle. So basically, it says that the high-level business logic objects, they shouldn't depend on low-level implementation details, and both should depend on abstractions. I think it's easier to see this with an example as well. So it's kind of a similar example to what we had before. I think it gives a good understanding of how the principles are interconnected, really. So here we have a reports generator manager class that generates an XML report. Here in this method, we generate this report and take some additional actions. So as you can see, the high-level class report generator manager is very coupled with the lower level kind of implementation detail sort of class, XML report generator. So high-level class depends on the details and kind of the implementation of a low-level class. So also, as you can imagine, if we want to add another class here, we would need to modify. So we need to add like a new low-level implementation detail class. We would need to modify this class, the high-level class. So it clearly breaks the dependency inversion principle. And the way to fix it is usually, again, with dependency injection. So dependency injection is not the same way as dependency inversion principle. It's just a tool that we can use to help our code actually not break this principle of S.O.L.I.D. So here on the right, you have the same class, report generator manager. However, the difference is that when you initialize this class, you always expect it to be initialized with a generator of some sort. So here, what this syntax means is that you are providing a default generator. So if you don't provide anything, the report generator manager will be initialized with XML report generator. And if you provide a new one, it will be kind of overwritten. And then here you can see we just have a method called generate report. It's very generic. And here we just call a method called generate on the generator. Again, duck typing, we don't care about the class. We just care that it has the method generate and it can generate its own thing. One thing that I wanted to kind of end with is that following those principles often makes testing much easier. And also the reverse is true. If you're working on the code and if you're writing tests and you see that it's very hard to set up the test, you can see that you need to mock a lot, that you are kind of confused, and more like, what have you mocked? You're not sure what's happening anymore. Very often it means that your code is breaking some of those principles of S.O.L.I.D or maybe other principles as well. So here in the before, you can see that we need to stub out all of the calls of methods of this hard-coded class. So we are using a verifying double, which is usually like a good thing. A verifying double is a double that checks whether the methods called on the double actually exist on the real object. So, but here what it means is that if the XML report generator changes its method from generate to say generate report or something like that, this test would start failing, which is strange because we're not testing XML report generator, right? We're testing a different class. But those classes are so tightly coupled that it's impossible to kind of distinguish them. And like the whole thing just becomes a huge mess. And on the bottom here, you can see how this can be actually improved. With our refactor, we would just need to create a double, which would be like a totally fake object. It can be like generator instance. It's a fake generic object. We don't care about this object. Like, it doesn't matter. We're not testing it. We just care that it has the method that we need and it returns like something that we also kind of don't care about in this case. So the goal of unit testing is to test classes in isolation without worrying about dependencies. And our refactor class makes this thing easier. So this was S.O.L.I.D. This is a short summary of all of the principles. I'm curious to see whether, I remember that a lot of people wrote that they have never heard of S.O.L.I.D or haven't worked with it before. I wonder if your opinion has changed. Maybe you actually heard of S.O.L.I.D but didn't know that it was called S.O.L.I.D. So have you? Does S.O.L.I.D sound more familiar now? What do you think? Okay, I see that it's still new, but it's very interesting. Yeah, I'm glad that it was interesting. I hope that this can be like a good starting point for you to research S.O.L.I.D a little bit more and investigate it more. There are like so many resources about S.O.L.I.D in all different programming languages. So I'm sure that you can find it in the language that you work with. So yeah, just to end it with, I wanted to leave you with a little bit of a homework. It's not like really homework, but something that you might help you to think of S.O.L.I.D in the upcoming days and weeks. So let's agree that within the next 2 weeks, you can try to find a place in the code base that you work with. It can be like either your professional project or maybe your pet project. And you can try to think of how it can be made better with one of the S.O.L.I.D principles. I think that single responsibility principle would be the easiest one to find violations of and correct. So if it's a pet project, you can just go ahead and start refactoring the code. And if it's a work project, depends on the company, but if you plan refactoring in your work, then this might be something that you might propose. You can tell your manager or team leader that you would like to change the code to not break S.O.L.I.D, and then explain why, and you can explain how this would make it easier for you to add new features in the future, how this would improve the speed of delivery of features to your customers, and how this will bring your company a lot of money. Hopefully this might be sound like a fun project for you to get involved with. I think it's important to have some practice with things to remember them. Yeah, so that's it for me, actually. If you have any questions, let me know. We have a few more minutes, so I can try to answer them. Yeah, anything about any of those examples. Let me know whether this was useful, and what do you think of it? Okay, somebody writes that they're not very familiar with Ruby on Rails. Yeah, fair point. We'll have our future lectures within object-oriented design programming track. We'll have examples in many other programming languages. So I think that somebody will find, everybody will find something for themselves. Yeah, says Irina wrote, please join us in Slack. We will try to help you refactor your code and learn. Yeah, and as I said, please feel free to connect to me on LinkedIn or Twitter, wherever you prefer. Cool, I'll stop sharing them then. Yeah, thank you all for joining. Thank you all for listening.